First one, reaction with oxygen. Reaction with oxygen. Reaction with oxygen. Write down most of the metals, not all, but most of the metals combine with oxygen. Combine with oxygen to form metal oxides. To form metal oxides. Okay, here also exception is there. Silver and gold, they don't react with oxygen. Okay, see, we use gold or it is not silver oxide, it is silver sulfide. What when you keep it exposed, the silver plates, that black color coating is formed, that is not silver oxide, it is silver sulfide. It reacts with sulfur, not with the oxygen. Okay, so gold we use daily. We use the gold, right? Why we use that? Because they don't react with oxygen, water, all this. See, iron we don't use, right? Why we don't use like ornaments and all? Because it will get rust. But here we use the gold mainly because it doesn't lose its properties. They don't react like that. Okay. And the iron we use in buildings and all. Why? Because they are very hard in nature. They have high melting point, high boiling point, and it's very hard. Yeah. So that is why we use that. Okay, because of its properties, we use those things. Okay, so if you know the properties, because of that only they will be able to use that. Okay, now we will study about the reaction with oxygen. Write down silver and gold. Write a note, silver and gold do not react with oxygen. Okay, they don't react with oxygen. So other metals, how they react? First, the metal plus oxygen. What you will get? Metal plus oxygen. We get metal oxide. Metal oxide. Metal plus oxygen, we will get metal oxide. Example, copper plus oxygen, we will get copper oxide. Copper oxide. And this is black in color. Okay, this is black in color. You should remember that color, texture, whatever they have given in the textbook, because sometimes they give it a black oxide is formed or black powder is formed. And you have to write the reaction. Like that only questions comes in the chemistry. You should know. It's a black powder. Copper with oxygen, you will get copper oxide. Next with aluminium, another example, aluminium plus oxygen. What you will get? Black. It is not gray. Silver chloride is gray. Copper, no, that is different. That is what you are telling green. That is corrosion. That is not only oxidation. It is what you call cuprite. We call it as cuprite. That is different. That is different. That composition itself is different. Silver chloride is white, no? When it's exposed to sunlight, it becomes gray. White, when it is exposed, it becomes gray. So because it is, silver is gray in color. Yeah, so then, which one? Aluminium. Gray color. Gray color. Aluminium oxide, what is the formula, Karthik? What? Aluminium oxide, what will be the formula? Al2O3. Because aluminium valency, it is 3, oxygen valency 2, cross multiply, 2 aluminium combines with 3 oxygen, it forms Al2. Now balance this equation. Balance this equation. Everyone. 6. 4. 4Al 3O2. 4Al 3O2. What you will get? 2Al2. Okay, right now. First one, second one, done. Write down written. Understood? So how you get Al2O3? Understood? No. So valencies, aluminium valency 3, oxygen valency 2, cross multiply, 2 aluminium reacts with 3 oxygen to form Al2O3. Done everyone? Shall I clear? Yes. Sodium plus oxygen, what you will get? What you will get? Na2O. Sure. By sodium valency 1, oxygen valency cross multiply. 2 sodium reacts with 1 oxygen, you will get Na2O. That is sodium oxide. Okay. Then potassium K. K plus oxygen, you will get K2O. Potassium valency 1, oxygen valency 2. So you will get K2O. This is potassium oxide. Yeah. Only. No, Na2O. What you O2 only. Yeah, balancing act to this. Make act. Balancing. Yeah, O2 only. Correct. That is it. Still. You're telling O2 you should try. Yeah, that is it. This is solid and this is a gas. What you will get. And what you will get Na2O is a solid. Okay. Now, and write a note. Potassium and sodium. Sodium are very reactive metals. They will ask these questions. Very reactive metals when exposed to atmosphere. You keep it in the hand, it will catch fire. Your hand, then it is reactive. Correct? No, that's all. That's how you. Gold can it will catch fire. Yeah, it is immersed in kerosene and kept. It is metal. You will get in the. Here also it is an oxide form or some other sulfide form like that only. Separately, yes. Yeah, it's a metal. It is extracted from the ore. In the ore form also it is in some oxide form, sulfide form, carbonate form like that. It is not separately there. It's a metal like an iron. How you will get in ore? Like that only you will get sodium ore, calcium ore. Okay, and exposed to atmosphere catches fire. Right, due to exothermic reaction. Thermic reaction. Hence, it is immersed in kerosene. Hence, it is immersed in kerosene. Hence, it is immersed in the kerosene. Right. Written? Then, now we studied about the metal oxides, right? So, metal oxides, they are basic in nature. Metal oxides are basic in nature. Okay, write that note also first. Metal oxides are basic in nature. All metal oxides are basic in nature, but some metal oxides like aluminum and zinc. And what are they? Aluminum and zinc. Amphoteric in nature. Amphoteric means they act like a base. They act like base as well as the acid. Uh, like no, they act like a base and acid like nature. That means, see here, listen here, aluminum oxide or zinc oxide, they can react with the base as well as the acid. So what are no, it's alkalis. Wait 1 second. Listen here. Be quiet. Listen first. Metal oxides are basic in nature, but aluminum oxide and zinc oxide, they are amphoteric in nature. I explain about amphoteric so much discussion. We will know everyone maybe more points. It has the properties of both base and the acid. That is, aluminum oxide can react with the base. When it is reacting with the base, they acts as an acid. But when it reacts with the acid, it acts as a base. Okay, again I repeat. See, most of the metal oxides are basic in nature, but few are amphoteric. Few are amphoteric. What are amphoteric? They act like a base as well as an acid. Okay, they can act as both base and an acid. That is, example, aluminum oxide and zinc oxide. They can react with the base. When they react with the base, they act as an acid. And when they react with an acid, they act as a base. Okay. It's nature. That's how. When they react with nutrients like water and what happens? Why they will? So like suppose okay. When indicator you put what does it show? It's base of it. It's base of it. Okay. See, and when they show the indicator, right? When they dissolve in the water, only it will show. When they fill out the thing, it shows pink. Like that. Okay. So understood, na? Right. Third one. Aluminium oxide Al2O3 and zinc oxide ZnO are amphoteric in nature. They are amphoteric in nature. Okay, they are amphoteric oxides. Okay. They are amphoteric oxides. That is, they show both the behavior of acid and the base, then they have amphoteric. Okay. Strong bases, when they are strong bases, alkyls are the strong bases. That is, they dissolve in the water. Then they are called alkyls. They are strong bases. That is sodium oxide and potassium oxides. They will dissolve in the water. They are called alkalis. They are strong bases. Amphoteric, amphoteric oxide. Amphoteric oxides. Okay, amphoteric oxides such as aluminium oxide, such as aluminium oxide, zinc oxide, show both acidic and basic behavior. And basic behavior. Example, aluminium oxide is Al2O3. Okay, it reacts with an acid. So what you will get? Aluminium chloride. Aluminium chloride plus the water. If you balance that, aluminium chloride is what? It is in solid. This is aqueous. So aluminium chloride, it's an aqueous. Water, it's a liquid. Balancing it is 6, 2. Okay. Another example, aluminium oxide. It reacts with a base, that is NaOH. Sodium hydroxide and potassium hydroxide, they are strong bases. They are also called as alkalis. Why they are called as alkalis? Because they can dissolve in the water. They form this base NaOH and KOH. So a base, aluminium oxide with the base, they react. Then here on the see, it's a base with an acid. What you will get? Salt plus water. Here also see, aluminium oxide with HCl, base with an acid, you will get salt plus water. So here it is acting as a base. Here it is acting as an acid. So it is showing both the behavior of acid and base. That's why it is called as amphoteric in nature. Okay, they are called amphoteric in nature. So NaOH, what you will get? Sodium aluminate, NaAlO2 plus the water. This is sodium aluminate. Aqueous means it is dissolved in the water. We call it as aqueous. Another note, right? Metal oxides are insoluble in water. All are not soluble in water. Okay, few are soluble in water, and but some metals like sodium, potassium dissolve in water to form hydroxide. Hydroxides. They are called, okay, alkali. They are called as alkali. Metal oxides, not all metal oxides are soluble in water. So the metal oxides, like for example, like potassium oxide and sodium oxides, no, they dissolve in the water. So they are formed. They are called as alkali. Okay, and they are strong bases. They are the strong gases. When they dissolve in the water, you will get hydroxide. We'll write the equation. So write down this. First, sodium combines with the oxygen, we will get Na2O. Correct? Now that it combines with the water, you will get sodium oxide with the water. Okay, you will get NaOH. This is aqueous. Balance 2. Yeah. Sodium, when it combines with the oxygen, you will get sodium oxide. That when it is dissolved in the water, they react actually. When the sodium oxide dissolves in the water, they react because they are very vigorously reacting. You will get NaOH, sodium hydroxide. Okay. Then potassium hydroxide, when it reacts with the water, you will get it is there. Here KOH, hydroxide only, no? Potassium oxide plus water, you will get potassium hydroxide. No, I told potassium oxide reacts with water, I'll get potassium hydroxide only. I told. Okay. Clear, no? So what and all now we studied chemical properties means it how they react with the oxygen, water, or any atmospheric gases, bases, acid, all these we call it as chemical properties. So first we study about how they form the oxides, that is how they combine with the oxygen. So when they combine with the oxygen, they form metal oxides. All metal oxides do not uh, dissolve in the water. Those which dissolve in the water, we call it as alkyls. And they have strong bases. Example, sodium hydroxide and potassium hydroxide. Okay. So most of the metal oxides are bases in nature. Most of the metal oxides are bases in nature, but aluminium oxide and zinc oxide are amphoteric in nature. That means they behave both as an acid as well as a base. They behave both as an acid and as well as a base. Okay, so that's why they are called amphoteric in nature. Example, aluminium oxide plus HCl, you will get aluminium chloride plus the water. Here, if you observe acid plus a base, you will get salt plus water. Correct? There, like that only the reaction is there. So here it is acting as a base. When aluminium oxide combines with the base like NaOH, you will get sodium aluminate plus the water. So there also a salt is formed plus the water. That means what? It is acting as an acid here. Okay, that's why it is called as amphoteric in nature. Even the zinc oxide is amphoteric in nature. So clear, na? Now we'll just see how all these will react. Now we know it is forms metal oxide, alkalis, all these things we have. No? Next we will see how they react with the water and all things we will try to study. That don't react with the water. Yeah, will get actually. Don't react with the water. Will come. Yeah, silver and gold. Yeah, they don't react at all oxygen. Gold. That's why it is like that. Gold and silver, no. Water it will come later. Each one it differs and explain. Yeah. Write few things now. Write down it. Order of reactivity. Write down this order of reactivity of metals with oxygen. First one, potassium and sodium reacts vigorously. They reacts vigorously with with oxygen, with oxygen and catches fire. Catches fire. So only it is kept in kerosene. Therefore, it is kept in kerosene. It is kept in kerosene. Magnesium and aluminium burns in air only by heating. Only by heating. That is magnesium oxide and aluminium oxide. It is formed only by heating. It is formed. Okay. And another important thing, magnesium forms magnesium oxide, aluminium forms aluminium oxide. Okay. And they form a coating on that. See, when aluminium combines with the oxygen, what forms? It forms an aluminium oxide. When magnesium combines with the oxygen, it forms a magnesium oxide. Okay. First, it forms a very thin layer. Okay, magnesium or aluminium, if you keep it, they react, but very slowly they react with the oxygen. Or when you heat it, burn in the air means when you heat that with the oxygen, it becomes magnesium oxide and aluminium oxide is formed. But when you keep it, like expose it to the air, what happens? Magnesium oxide and aluminium oxide is formed, and it forms a very thin layer of magnesium oxide and aluminium oxide. Okay. So when it forms a thin layer, it acts as a protective layer. So further oxidation will not happen. See, if you keep a magnesium ribbon, what they call, correct, magnesium ribbon, exposed to the air, what happens? It will form magnesium oxide coating, one coating outside. Okay. It happens slowly. Oxide formation, it very slowly happens, but a thin layer is happened. So after that, further oxidation will not happen because it acts as a protective layer. Because it acts as a protective layer. Similarly, aluminium oxide also, when aluminium oxide is formed, okay, aluminium, when you expose it to the air, it forms aluminium oxide. A very thin layer of aluminium oxide is formed, and that acts as a very protective layer. So further oxidation will not happen. Further oxidation will not happen with that. Okay. And when the first chapter, I think we studied, right? When magnesium ribbon is burnt in air, what they do first, they rub the magnesium ribbon and then it is exposed to the fire so that it forms magnesium oxide. You remember that we studied like that. Why it is rubbed? Because it forms a magnesium oxide layer. Uh, so then what it happens? It forms the protective layer. Then it is rubbed so that magnesium, that layer is removed. Then it is burnt in air. Okay. So magnesium oxide and aluminium oxide, they first a thin layer will be formed, which acts as a protective layer. Okay. Even in the aluminium vessels, it happens. Aluminium oxide is formed. A thin layer is formed, which acts as a protective layer. Because of that, further oxidation will not happen. Okay. And these questions they will ask why it is kept in kerosene or how it is aluminium utensils are protected. How means because aluminium oxide is formed, it acts as a protective layer and hence further corrosion is not possible. Okay. Write down that now. And it burns only in the by heating. That is, if magnesium has to become magnesium oxide, white powder in it, then you have to burn that in the air. That means it combines with the oxygen in a heat, then only it forms that. Okay. Galvanization is the zinc coating on the iron so that it will not get rust. Galvanized sheets and all it will come. No? The zinc coating is formed. Yeah, it is same as electroplating. Many times it is done by electroplating. Not only way, but very accurate. Easy way and accurate. Precision is too much high. That electroplating. That's why they do it. Most of the time they do. Okay. Write down and write whatever I told about aluminium oxide and magnesium oxide. Write down that. Zinc. Write down. Zinc burns only on strong heating. And burns in air only. Right? Burns in air only on strong heating. Then iron does not burn in air, burn in air as a rod. Okay, as a rod, but burns in the form of filing. In the form of filing. Write down, I'll explain. In the form of filing. Burns in air only on strong heating. Iron does not burn in air as a rod, but burns in the form of filing. Okay, copper burns in air. Burns in air. Burns in right. Wait. Copper does not burns in air. It does not burns in air, but blister copper reacts with oxygen. Blister copper reacts with oxygen. Silver and gold do not react with oxygen. Okay, they do not react with oxygen. So now what I'm going to study first thing, potassium and sodium, they are very reactive. Just you expose to the atmosphere, they react with the oxygen and they catches fire because combining with the oxygen, it is a very exothermic reaction in sodium and potassium. So it catches fire. Okay, so this is about sodium and potassium. So they are immersed in the kerosene. When you consider the aluminium or magnesium, when it is exposed to the air, they slowly react and they form magnesium oxide and aluminium oxide, but very thin layers formed. After that, further oxidation is not possible. So when they form the complete magnesium oxide or aluminium oxide, when it is burnt in air. Burnt in air means heating with the oxygen. Because when it is burning with the air, it takes oxygen and burns, no? Then it reacts with them like that. Okay. So magnesium and aluminium, it burns in air. Only then it reacts. Now, what about the zinc? When you heat it strongly only, then only it reacts with the oxygen. Okay. Iron as the rod, you can't combine with the oxygen, but iron filings, if you take, when you heat them, it reacts with oxygen and forms iron oxide. Okay. Whereas the copper, even the filings, they don't react. When it is blister copper means it is heated in the furnace and all, right? As blisters will be coming, that is, it becomes a liquid copper. So much it is heated, then it reacts. Blister copper means it forms a liquid. Then that is heated in a furnace for something, right? There it becomes a blisters of copper, they say, no? That time it reacts. Whereas silver and gold, they do not react at all. That is why silver and gold are precious, because they don't lose its properties. That is only one of the big reasons why they are very important or it is used.
Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.